To another webinar by Digital Vidya. The topic for today's webinar is Say Yes to NoSQL. And in this webinar session, we will start with a small description of what NoSQL is, and then we'll try to understand why is it we have introduced it at all. And then we'll also take a look into 4 different types of NoSQL frameworks, and we'll share some tips on how to choose what kind of NoSQL platform. And for leading the session, we have Dr. Rohit Kumar with us. Um, Rohit has actually done his dual PhD in computer science and big data domain from ULB, Belgium, and UPC, Spain. He has several publications in top international data mining and database conferences, and is currently working as a researcher in Eurocat, which is a big data analytics lab. And he's also a trainer with Digital Vidya for the data science course at Digital Vidya. So over to you, Rohit, and thank you for coming into the session.
Thank you, Divya, and hello everyone. So today's session, as Divya mentioned, would be about a small introduction to NoSQL and why we need it and how we can use it. So before we start the session, I just wanted to get a quick understanding of everybody who is joining and what is their background. So we have some poll questions which will let me help to understand the audience. So Divya, can we have the first poll question?
Yes, I've just shared out the poll question with everyone. And yeah, just select which category you belong to. So we have got around 60% of the responses by now. We'll give it another 10 seconds to complete, and then we'll show the results to all of you. So here are the results. Around 27% are students, around 55% are from IT engineer background, 9% big data engineers, and 9% managers.
Okay, good. And can we have the second poll now, please?
Sure. So here's the second question. Have you ever worked on any NoSQL platform? If you have, select yes. If you haven't, then select no. Guys, quickly fill in, just select the option which you belong to. We have received 60% people, response from 60% of the people. Another 10 seconds. So here is the results. So actually, none of you have ever experienced or have ever worked on any of the NoSQL platform.
So I hope by the end of this session, everybody would say yes to NoSQL and try to use it. So can we have that last question, third question as for the poll?
Sure. Launch the last question. Do you have any basic understanding of database system? 40% have voted. Select a yes or a no if you have ever experienced database systems, then select a yes. If you haven't, then select a no. Okay. We have received approximately 70% of the responses, and here is the result. So 93% of the audience has not ever do actually have basic understandings of database system, while 7% of these don't have any understanding.
Okay, so that's very good. So people are working on database systems, which is quite common if you're from an engineering background. And NoSQL, if you have not worked in, it's okay. Today you'll get a preview and then you can decide to say yes or no. Okay, so let's start with the session. So before we go to NoSQL and why NoSQL, let me just do this marketing question and try to emphasize about big data. So big data is a term which I'm sure most of you would be hearing quite often now if you're working on big projects. So what is big data? So actually big data is nothing but it's an evaluation of the data over time. So when the IT system started some decades ago, we had ERP systems. Like this was the first generation of systems which came in where the system was supposed to do what? It was supposed to record some purchase details, some purchase, so ERP systems where you do some purchases, then those records are saved. So these were very simple systems. So the amount of data at that time was in few GBs. But then the requirement increased and people wanted to store more data. So apart from their purchase detail, people started, the companies thought, okay, let's get support contact details, that how many calls we are getting for support, what is the information of customers we can keep in. And then a CRM kind of system came in and the data storage increased even more. And we reached to terabytes. But now in the model world, we want to store everything. So we have new devices, the IoT devices. We have so much data generating from web, multimedia and social media. And companies want to store all this data and analyze all this data for businesses. And this is what is we call as big data because it's in very huge in size and there are some other variants to it like velocity, etc. So these are in petabytes, exabytes of data, and these big data is the challenge to address which NoSQL was kind of introduced. So let's see some interesting facts about this big data first. The scale of the data. So there is a prediction that by 2020 there would be around 40 gigabytes of data which will be created, which is around 300 times more than 2005. One of the major source of big data is cell phones. So there's an estimate that around 6 billion people have cell phones with a world population of 7 billion. Right? So more than 80% of people using phone and there's telecom data, right? Now, apart from this huge size, there is also speed, the velocity of data. So data is arriving at a huge speed now. Like for example, in New York Stock Exchange, we see 1 terabyte of data is getting generated for each trading session. If you work in machines, a jet engine can generate 10 terabytes of data in 30 minutes. And all this data needs to be analyzed. And then there is this sensor data from everywhere coming. For example, in energy sector, we have all these sensors deployed in the energy grids, which generates lots of data continuously. Now, these were about velocity and the volume of the data. But apart from this, the kind of data which we are storing is also changing. So there are now different forms of data. Now it's not straightforward records and rows and purchase history which needs to be stored. These are different format. There is photos, there is video, there is unstructured data now, right? So all this was a big challenge for traditional SQL based systems to handle because they were not meant for such a usage. So okay, traditional system can scale, but they cannot scale to such a high demand of streaming, or they are not usable or very useful for different forms of data, right? So to handle this challenges which was introduced by big data, NoSQL was a very popular choice. So if you are working on big data or if you are planning to work on big data, you have to use NoSQL. You cannot stick to SQL based systems. So what is NoSQL? So I'm giving it as a cloud because it's actually a combination of lots of different platforms. It's not a straightforward definition of NoSQL. Okay, so it's, if you call it, it's not structured query language. Okay, so it's a schemaless relational table database. But in a nutshell, we can describe NoSQL as a system which is inherently scalable. Okay, so it supports scalability inherently. Second, as required, it is blazing fast. So obviously to make it so fast and scalable, there's some cut downs. Okay, so for example, SQL guarantees that okay, on your relationship, whichever foreign key constraints, etc., you have put in will be checked when insert, and there is data consistency. Okay, NoSQL is a bit lagged on data consistency, but they are scalable and fast, and they actually eventually catch up for the consistency part. And finally, what we have is the flexibility and ease of use. So this is the most important feature in NoSQL, which is liked by all the developers. So if you are from a SQL background, whenever you start developing a system, what is the first thing you do? You define a schema. You think about all the different kind of data which you have to store, how this is the relation between those tables. Then you define your schema, and then on you can start saving the data, right? But in big data, you don't have so much time. You don't know what kind of data you are going to get. So NoSQL gives you the flexibility that you don't have to define a schema. Okay. So let's do a comparison. So now we want to see SQL versus NoSQL. Obviously, you need both. You cannot say that, okay, I'm going to use just NoSQL. So it's use case basis. So by the end of the next slide, we'll see, okay, why SQL is needed and when SQL is needed. And we will also see when NoSQL is needed. Okay. So let's do a comparison between SQL and NoSQL. As I mentioned, the first thing is the modeling part. So if you understand data modeling, if you have worked on databases, data modeling is a concept where you decide, okay, how the data has to be stored, what is the kind of attributes you have in your data, etc. Right? Now in SQL, it's on relational model. So you define your table. For example, you can have a customer table, or you can have a sales table, and you can say, okay, one in customers table you have one row for each customer, and in sales or purchase table there could be multiple sales done by a customer, right? So this is how you define your relationships, and then you define your schema. Now in case of NoSQL, there is no relationship definition needed upfront. Okay, so you can have ad hoc structure. For example, you can store data as a JSON document. Now JSON documents, if you know, is a free formats with key value and with some attributes and values. It has a structure, but it is not strict, that you don't have to define the structure beforehand to store the data. So you can store as you go. Then there are some interesting graph-based structure which is possible to store. So graph databases is part of NoSQL system. So they are kind of more complex data models. So we'll see about graph when we come to graph databases, but they are like connecting relationship between nodes and all. Okay, so these are different kinds of non-relational data models are very nicely captured in NoSQL databases. So if you have a system or a project where you have requirement to store unstructured data which you don't know before how you're going to process it, but right now you want to just store it, and then later on decide, okay, we have the data, now how should we process it, etc. Right? Or you want the flexibility to change it very often, or the cases are that you have relationships, complex relationships to be stored. In that cases, NoSQL is a good choice. Then what kind of data? So we already talked about it in part of data model. So you can, if you are using a NoSQL system, you can add properties on the fly. So today you are storing suppose 4 properties, and tomorrow you realize, okay, you can store 6 more properties for the attribute which you are storing. In SQL, if you remember, you have to edit your table. So if it's a table with 4 columns and tomorrow you have to add 3 more columns, you have to edit your table, then give some default value to existing data, and then it's a mess, right? So if there is a relationship, you have to update all those things. In NoSQL, you don't have to do it. It's automatically taken care of. Okay, so you can add properties on the fly. Also, we talked about relationships, right? So we have these relationships stored in SQL tables. Now there's a concept called denormalization, right, where you store all the data as single data point. So we use denormalization to represent data as a single record in NoSQL. Why? Because this helps us to make the system more fast. Okay, so you don't have to divide rows, join them later when it's needed. You can keep everything together, right? So this helps to scale our NoSQL databases a lot. Obviously, you can do the same thing in SQL to store everything in a single row, but then the flexibility you have of updating, etc., is not as easy as in NoSQL. And as I already said, NoSQL is very good for semi-structured data. If you have very structured data, like if you're building an ERP system for customers and customer purchase history, there is nothing which can beat SQL. But if it is unstructured or semi-structured data, then you have to go to NoSQL. Then schema. So there is a flexibility of schema, but in SQL it's a strict schema. You cannot break the schema rules. Okay, so whatever schema you have defined, your data has to be in the same format. Okay, but in NoSQL, the schemas is flexible. It's dynamic. Now, when we come to transactions, here SQL is better. So SQL supports ACID transaction. NoSQL does not guarantee it. It's ACID transactions supported depending on different various solutions. Okay. So if you have transactional system, generally it's relational based systems, and you go to SQL. Now consistency. What is mean by consistency? That okay, what you have stored, and if the system says that okay, yes, this is stored, then you know for sure that this data is consistent in your server. It's stored. It's persistent. Now SQL guarantees strong consistency. So when you store or insert some data in SQL, and the system tells you okay, insert successful, you know for guaranteed that okay, whenever you want to read, that data is there. Now in NoSQL, it's tunable. So it is consistency. So if you have worked on distributed systems, you will know that okay, for NoSQL, because it's not one single system which we want to use, it will be a distributed system. So the consistency part varies. So it is eventually consistent, but it does not guarantee real-time consistency. If it says okay, I've stored the data, it might be that when you read it, that there's a lag. So you get the consistent data after some time. Okay. Now, in some use cases, you might not need consistency so much. So you're okay that, okay, I'm eventually consistent, but not real-time consistent. Then I'm okay. But in some cases, it's not okay, right? So let's take an example. Suppose you're doing a purchase or buying some things like stock market trading, etc. Okay. There you want consistency at real time. But if it's a social media post, okay, so you posted something on Facebook and all of your friends will not see it at the same time. It might be a delay that okay, some people in the US see it after some time. Okay, or it's a Twitter post. Okay, so in that kind of use cases, eventual consistency is okay. You don't need something very strong consistency, right? So depending on use case again. Now scale. So NoSQL systems generally scale horizontally. So what you mean by horizontal scale? Horizontal scaling means tomorrow you have two systems and you are able to support 1 million users. After 1 month, you get 10 million users. So you have to just add 3 more servers horizontally. So just keep adding boxes of servers and you're getting scale. In SQL, it's not very easy to horizontally scale. Okay, so there are provisions. I will not say it's not possible. So there are provisions to horizontally scale also. But mostly traditionally SQL systems are vertically scaled. What does it mean? That okay, you have a system with suppose 20 GB of RAM right now, and you store and 1 TB of hard disk, and you are storing data. Tomorrow, your customer base increased to 10 times. So instead of that one small box of 1 TB of disk and 20 GB of RAM, you create a bigger server with 80 GB of RAM and 10 TB of hard disk. and then you migrate your data. Now this is your big server, right? So you scaling vertically is easy in SQL. Obviously, horizontal scaling is there, but it's not as straightforward and as easy in NoSQL. Okay, so NoSQL gives like easy to scale horizontally methods. Okay, so this is one of the reasons why NoSQL is becoming so popular, because you don't have to buy very costly hardwares, right? Because vertical scaling is very costly. When you buy a costly hardware, the price increase is not linear. So if you add two servers, two cheap servers, like 10 terabytes together, or if you make a bigger server of 10 terabytes to 20 terabytes, the price is not same. So vertical scaling is always very costly, and that's why it's not preferred so much. Okay, so I hope with this table you get a comparison between where NoSQL and SQL comes up. Okay, and this will give you some idea that okay, in what kind of scenarios you should use SQL, and for what kind of scenarios NoSQL would be better. Okay, so for just to recap, if you have a very strong consistency requirement, ACID transactions, relational data, then SQL is okay. But if you are relaxed about consistency, you want more flexibility on what kind of data and how you want to store your data, and you want horizontal scalability, then NoSQL is good. Okay, so I think we have kept all the question for end. So let's move a bit more deeper in types of NoSQLs. Okay, so broadly there are four kinds of NoSQL systems which are around. Okay, key value stores, column stores, document stores, and graph databases. Okay, so all these are NoSQL databases because they are have these common properties which we discussed. Okay, but the way they store the data itself is a bit different, and based on that difference, the NoSQL databases has been divided into these four categories. Okay, so the first category, key value store, is the most simplest NoSQL database. Okay, so if you are as most of you were IT engineers, as I can recall from the poll, think of key value store is nothing but as a hash table or hash map, where your key is some particular ID and value is your data. Okay, so you store in key value, and these are useful in different scenarios. For example, Azure table or React or Redis are good examples of key value tables. Okay, so for caching, suppose, okay, so you have a user profile to be stored and you have user ID. So if you make user ID as a key and user profile as a value, then accessing this value for any user at any time is very fast because it's by key. Okay, so performance is very high in key value, scalability is very high, and there is very high flexibility. Okay, because the value could be any structure. The only problem is this complexity is very low, it's almost none. Okay, so the only way you can query this databases is by key. So as long as your data you need to access is by key only and no other attributes, then key value stores are good. Okay, so it does not have any complexity stored in etc. Just key associated with a value. Now the other one is column stores. Okay, it's also known as wide column stores. Now instead of storing data in rows like in traditional database systems, here the data are stored as sections of columns. Now this is a bit more complicated to understand how it works, so I will skip it because we don't have so much time to go into detail. But just think of column stores as a column-wise storage system instead of a row-wise storage system. Okay, here also it's very high in performance, very high in scalability. The flexibility is a bit moderate, it's not as flexible as key value store. Okay, because you have to define some column structure, etc. And complexity is low, so you cannot have very high complex data structures here. Okay, But column stores are very popular. So if you might have heard about Cassandra, Google, Bigtable, HBase, all of these are column stores. Okay, and on column stores databases gives you a SQL-like query structure. Okay, so if you use HBase for example, and you run some query on HBase, it will give you a SQL-like feel. Okay, but underneath it is not a structured data. Now the third and the second most useful data store is document store. So MongoDB or Couchbase. So MongoDB is becoming more popular now as a document store. In MongoDB or in document store, what you store is a whole document, okay, which is nothing but a JSON file. So you defined a document structure with attributes, a structure of the document, which could be edited and it's not fixed. And so there is flexibility, everything. But again, the complexity is low, okay, because you cannot define relationship between different documents as such. Okay, so it has high performance. Scalability is variable, but it's on the higher side still. So some like MongoDB is quite scalable. Okay, there's high flexibility because you can change the structure of your document at any time, but the complexity is low. So example is MongoDB, Couchbase, etc. Okay, now finally the most complex NoSQL database is your graph databases. Okay, so the complexity is very high. Why? Because you can define very complex structures of your data. Right? Okay, you can store a whole social network graph of friends and friends relationship, etc. in the graph database. So graph databases allows you to store complex relationships. It is highly flexible because that's the trademark of NoSQL systems. But here the performance and scalability is variable. It's not as high as other NoSQL systems, which makes sense because you are giving more complexity to be stored. So whenever there's more complexity of data to be stored, performance and scalability suffers a bit. Okay, but still, compared to SQL-based systems, graph databases is very good for relationship storages. Okay, so if you have, I don't know, friends network, suppose your Facebook network data you want to store, that who is whose friend, etc., who is talking to whom. So this is a graph network, right? So storing it in a SQL server and then doing a query of graph like, okay, how many friends of friends I have will take a lot of time compared to a graph database where it will be very fast. So any graph based data is much easier to store and access in graph databases. The most popular graph database right now is Neo4j. So anybody who works or want to work on graph databases should look up Neo4j because this is the, so there are others like OrientDB, for example, is a kind of database which supports graph queries and it supports graph databases. But Neo4j is the best one which is available right now. Okay. So this is an overall picture of different kinds of NoSQL tables, databases which are there and how they vary based on performance, scalability, flexibility, and complexity. Now, what's the next? How you decide which one to use. So first, you have to decide whether you want to use SQL or NoSQL, for which it was an easy answer, right? So, okay, structured data, relationships are string and unit consistency, like a typical ERP system, okay, SQL. But okay, when you have decided that you want to say yes to NoSQL and you want to use NoSQL, then what? There are so many different kinds of NoSQL. Inside a NoSQL, as I said, for key value, there are RAG, Redis, etc. For column store, there's HBase, Google Table, Cassandra, etc. So how at the end when you decide which kind of database to use? How should you decide? So for me, whenever somebody asks me as a big data consultant or as a big data researcher, how should I know which NoSQL database should I use? So I tell them first step is read. Okay. So not everyone is an expert. Most of us are not an expert. I don't think even I am an expert. So first thing is you should read. Read about all the various type of NoSQL databases which are out there. the popular ones like Neo4j, Cassandra, HBase, Redis, etc. Okay, so get a basic idea about them. That what are these various types and how they work. Okay, so this is most important to keep reading to get at least a basic idea of how the data structures are, how the data is stored, how the indexing is done, etc. So get these few answers for all. You don't need to know the complete usage of the database, like how to run a query on that database or how to partition that database. Okay, but a basic understanding of each NoSQL databases, which category they are in, etc. is needed. So this is the first step. And once you have done this, you have some basic understanding. Okay, sorry. Yeah. Then you go to the step two. What is step two? Investigate. Now, this is the most time-taking process in any project. Okay, so you have to investigate all the use cases of your project because there is no simple checklist to decide. So when you evaluate all the use cases of project, okay, what are the different data sources? Okay, from where you are getting data, how you are getting data, what is the frequency of your data, etc. How you are going to use that data, in what other formats you are going to use that data. Investigate all these use cases. This will help you to identify which type of NoSQL system you need. Okay, and remember, it's not one size which fits all. So I have worked on projects and there are many such projects which have multiple mix of systems. Okay, so you store some kind of data in some systems, like a document store, some on SQL maybe, and some in maybe a key value store. So you could end up with a combination of SQL, NoSQL. Inside NoSQL, you can have some data sources in MongoDB, some in HBase. Okay, so when you are working on a project, depending on the use case and how the data is and how you're going to use it, you could have a combination of all this. And finally, once you have decided, okay, I want to use a SQL table, I want to use a document store, and then I want to use a key value store. Suppose these are the three decisions you have decided. That okay, these data will go to SQL, this set of data will go to key value store because I just need to use the key to access it, and other these kind of data will go to a document store. So you have done step two. Now the step three is for each type of NoSQL database, you have to decide which one to use. So if it's going to be document store, so whether it should be MongoDB or Couchbase. If it is key value, whether it will be uh, RAG or BarclayDB or DynamoDB. So there are many systems which provides key value store, right? So there you have to see the ranking and the popularity of the selected system. So generally people go with the most popular, but do some more digging, look into the pros and cons. So which gives specifics. So if you are planning for a horizontal scale with mixed hybrid system, which supports that. So do a small comparison. Mostly I have seen people going with the most popular ones. So document store, they go with MongoDB, or depending on how kind of resources they have. So they have expertise on suppose Couchbase, they will use Couchbase. But if you're starting off and it's your first project, dig deep a bit more on specific kind of databases. That okay, what is the advantage of Couchbase over MongoDB or MongoDB over Couchbase before deciding which one you will use as a document store. Both are document store. Okay. Now, after doing all this, there are lots of other technical questions which you have to answer. Okay. Actually, these technical questions I have taken from a blog. Okay. But you should be able to create such technical questions based on the three steps you have done. So if you have done those three steps properly, at the end you will have such questions for which you have to find answer. So I will not go into details of all of them, but few of them let's see. Like for example, one of the questions which can come up is, so these are all technical questions which you have to answer. Can the database serve as the primary data source for the online application? Okay, so you have to see, okay, if it is the primary data source, or there is some other primary data source and this is just a secondary data source. Okay, so this is one question. Or we can take this question, is the database fault tolerant? And is it capable of providing continuous availability? So do you need continuous availability? Is it fault tolerance? What these terms means, if you don't know, don't worry. Let me give you a quick introduction to that. Fault tolerant means, okay, if you have a system cluster of 10 servers which are working as your database system, what happens if two of the system crashes? Will the system halt, or will it work still without any stop? Okay, so you have to find out if you have such requirement. If yes, which systems provides that? Okay, security could be one of the things. Does the database provides a robust set of security features? Okay, so how much security you need, what kind of security parameters you need, which database has what kind of security parameters depends. So you decide based on all these questions, answer. As an expert, you have to answer all these questions to find out what needs to be done. Okay, now the list goes on. For example, one of the questions could be, does the database require special caching layer? Okay, if yes, then you might decide to use key value store. Okay, now these questions which I'm showing in here is not the exhaustive list. So there's again no checklist for deciding which system to use, how to use it. Okay, as long as you follow the 3 steps, which sounded very logical and easy, but people sometimes miss it. Okay, so if you follow those 3 steps of reading, identifying, and investigating, then you will already come up with these questions which you need to answer. And there are many forums online with blogs with such questions. Some of the question may not apply to you. Okay, so you can totally ignore them. But I recommend everybody to come up with these questions themselves for their project and for their requirement. Okay, as I said, next goes on and on. But after answering all these technical questions, so there could be like hundreds of technical questions for which you find the answer, and then you decided, okay, voila, I'm going to use MongoDB, I'm going to use Oracle SQL, I'm going to use Azure tables. Okay, is it enough? So my experience is no, because only technical consideration is not enough. The business decision, the business consideration is very important too. Okay, so if you are working as an architect neighbor and not simply as a data engineer, you have to think about some other aspects other from the technology behind it. So you have to think about the business need. For example, you have to think about what is the community support. So most of the NoSQL systems which are out there is open source. Okay, so you have to see, okay, when the system came, is the community active for that system? If there are so many problems, are the people answering the questions? You go to Stack Overflow, you see many people answering questions. Okay, so you see what is the community for behind that system. So our open source system, if it has a big community, it's always good, because if you're stuck, you are not alone. There are lots of people all around the world who can help you. So the first recommendation I have for anybody who uses an open source NoSQL system is to always see the community behind, if it is an active community or not. Because if it is not an active community, even if the system promises good things, you should be very resistant to use it. Why? Because if you are stuck, and you will be stuck at some point, you will not get help, because there's nobody out there working on that system anymore. Okay, then the second consideration is fee, of course. So which system cost how much? Obviously you can buy the best ones, but the best ones also cost a lot. So you have to think about, okay, what is the fees, enterprise fees, support, etc., how many documentations are present, etc. So after doing these non-technical evaluation also, finally you can come up with a decision of what systems to use. Okay, and the final thing is resource and deployment needs. So if you already have resources who are experts in MongoDB, then anytime you want to use document store, you will use MongoDB. You don't want to hire. So this is more like a managerial question for managers. You don't want to hire new resources and teach them Couchbase, etc. Right? So depending on where your expertise are, or where your team's expertise are, it also derives kind of usage in one particular database system. Okay. Now Finally, I wanted to touch base quickly on two use cases where NoSQL has proven in industry to be very better or much better than SQL-based systems. So you might have heard IoT devices a lot, like smart cars, smart devices, smart machines, etc. Right? So IoT data or IoT data storage, IoT data processing is one of the industry use case where NoSQL has seen a lot of boom because of all the things we talked about: flexibility, ease of use, scalability, etc. Okay, and the second one is social network analysis. So anybody who works on social network analysis, you know, this graphical kind of data, it's very well stored in a graph database. So that is also a NoSQL database, for example, Neo4j. So these two industry use cases are very popular use cases for NoSQL systems. There are many more, but I wanted to point out these two because in these two areas I have seen. So if you are working in IoT based system, you can directly know that you have to use NoSQL, because now I don't see any cases where people don't use NoSQL if they are working on IoT, or if they don't use graph databases or any graph based system if they are not working on social network. So in these two industry cases, you don't even have to think if you need NoSQL, yes or no. It's always yes. Okay. Other cases, okay, you have to investigate and find out. But at least in these two use cases, it's always yes. Okay. So that would be the end of my presentation today. And now I'm open to take any questions first. So Divya, are you there?
Yes, I am. So,
Um,
guys,
so
let's. I think okay.
yes, I was asking, let's do the question first and then we do our quiz.
Sure. So guys, just feel free to share your questions in the chat in the questions tab on the right side of your screen, and we'll start taking up all your questions one by one. Currently, we do not have any questions, so just we will give another minute for all of you to put in your questions, and then we read out the questions. Also, if you missed the session a bit, if you joined in late, you all will get the recording of the session by probably by end of this week or early next week, along with the presentation. So don't worry about that. You will get the access of both the things to your delivered to your inbox. So I'm getting some highs. I believe you all are typing on the question. The first question we have got is, if it is possible, you can show us what's the basic structure of NoSQL.
Okay. One request, so I cannot see the names. So while posting your question, if you put your name also in part of question, then I can address you with name. So let's take questions one by one. Can you show structure of NoSQL? Okay. So there is no structure in NoSQL. So what do you mean by structure of NoSQL? So as I said, NoSQL, depending on which kind of database you are using, okay, it has different way of storing that data. Okay. So for example, MongoDB is a document store where your data is stored as a JSON object. So have you ever worked on JSON? So let me quickly see if I can show you a JSON object. Okay. So can everybody see my screen? Yeah. So like this is a JSON object. Okay. So this is an example of a typical MongoDB document, that how it is stored. So there's no specific structure of NoSQL. Okay. Depending on what database you are using, it will use different kind of data to store it. Okay. Which database is needed in IoT project? Again, there's no one single question depending on what kind of data you have. Okay, so the examples I have worked on in different projects, we have used Cassandra and we have used HBase depending on use cases in different IoT projects. Okay, so these are quite used databases in IoT. Um, I had heard about NoSQL database called MarkLogic.do. MarkLogic. Do you have any idea about it? No, sorry. So I've never heard about this MarkLogic. And NoSQL database domain is so big that there are more than 50 database systems now. Okay. So if it is a new database system, please be very thorough about using it. Check if it is open source, how is the community, who is the contributors, etc. Okay, because there are many NoSQL databases which promises a lot of things. So before you start using it and invest your time on it, make sure to find out if there is an active community, yes or no, so that if you're stuck, people can help you. Okay. What industry do you see coming up in future using NoSQL technology? Is it a viable field to pursue? From Dan. Hi Dan. Yes, I see NoSQL coming up almost in all projects now. Okay, except traditional ERP based systems. So if all old banking systems, even there, now they have requirements of social network data to be stored and they want to analyze their customer profile, etc. Okay, so even banking clients, they now are coming up to us and asking us, okay, how they can use NoSQL to store their customer data, their codes, etc. Okay, so if you are going to work on database technology, please start working on NoSQL. It's one of the future. It's a huge future. Okay, so I recommend it to everyone. I joined Nate. So people who join Nate, you can revisit the webinar. Okay, NoSQL going to be used popular as SQL or in medium scale companies and big companies. Surendra. Surendra. So from my personal opinion, NoSQL is going to be as popular as SQL. So you said SQL or Oracle. So actually that is quite funny because it's same. So Oracle is just a company which provides SQL databases, right? So NoSQL is going to be as popular, yes, and I think even more, depending on how the big data growth is going on. NoSQL are also divided into ONAP and ONTP. It can do both. Some NoSQL systems have data pipelines for ONAP and ONTP. CAP theorem is must considered in selecting the NoSQL design phase. Yes, I didn't touch base CAP theorem. So actually there is so CAP theorem, if people who have worked on databases will know, and there is a mapping of consistency, availability, and performance, etc., to choose which NoSQL system you want to use. Okay, so depending on the requirements of your CAP theorem, you can choose appropriate. There's even a diagram which is quite popular on this, which map up NoSQL based to the CAP figure. Okay, next question. Can I use DynamoDB as per document store? Because DynamoDB is paid, I have project to connect all the sensor data. Okay, so DynamoDB I have not used personally, but it's not very popular as a document store. It's more like a key value store. Okay, so what you need, if it's a document store which you need, then maybe CouchDB or MongoDB. DynamoDB is more a key value store. It's not known as a document store. But in value, you can actually store a document, but then you cannot query on that value, okay, or filter on that value attributes, etc. So depending on use cases, if you just need to access by key, then DynamoDB is okay. Okay, I have a project to connect on the sensor data from, okay, this question is not, okay, SAF. In MongoDB, can files be stored in other server like we do in relational models? Yes, so MongoDB is very efficient in data sorting. So you could have data stored across different servers done automatically by MongoDB by just doing a configuration. Okay, so horizontal scaling is much easier in any NoSQL database and of course in MongoDB. Can data files be online and offline when needed in MongoDB? Okay, I'm not sure what you meant here. Can data files be online and offline? So yes, it's persistent. So the data is stored in disk. So even if the server shuts down and restarts, it will have all the data. If that was your question. Okay, okay, Jay. Can you tell the difference between Redis and MongoDB? I always thought Redis stores data in JSON structure. Is it true? So MongoDB is a document store, okay, and or a document database. Redis is a key value database. Okay, so the difference between these two will become more clear if you read about key value store and document stores. Document stores are a bit more complex because it allows you to query based on the structure of the document. Key value is only big key based. Okay. Redis allows JSON structure. Yes. So in value, you can store JSON. So you can store anything in the value. It could be a movie also. Okay. What is the demand in today's market as per job perspective? It's lots of demand. So if you're an expert in MongoDB or in Cassandra, but remember, the downside of working on NoSQL is there's so many systems that you have to be an expert in. So there's lots of learning to do. So you cannot just learn MongoDB and expect that there will be too many job offers. So there are projects where people ask for specifically one kind of NoSQL database, but in general, 95% of cases, you should be good in all the four categories. You should have some understanding of all the four categories. So there's lots of reading to be done about different systems. And this is a challenge in big data. So big data systems, there are so many different varieties and flavors of it that it takes a lot of time. What I can propose you or what I can recommend to other students I do is that, okay, focus on a domain maybe. So you can focus on IoT and then start with IoT data models, systems used on IoT data processing, and then you are a NoSQL experts for IoT data. Okay, or you are a NoSQL expert for social network data. So these are kind of narrowing down your field a bit. Okay, people, if they put questions in two sentences, it's broken, so I cannot understand. So I will move on. How to start learning NoSQL? Any popular site to learn NoSQL? Okay, so there are many online tutorials on NoSQL. Okay, personally, I read it from books because I prefer books over online systems. But either you can do these courses, which are instructor-led courses with assignments, etc. Because I've seen people, if they don't do assignments, then they stop in between and then they don't understand the basic usage of it. Okay, so look, so EDX, I don't think Digital Vidya has a big data course yet, but there are EDX, Coursera, etc. They have courses on NoSQL, which I like because they comes with assignments, etc. Okay, so whenever you start learning NoSQL, start with assignments. Do some project on top of it. Just doing the theory will not help. Okay, to retrieve relational database data, date we use SQL query. What about here? It is not structured. Okay, to retrieve relational database date. I'm not sure what the question was, but I think the question was in relational database you can get date using SQL query. How about unstructured, not structured database, right? So, but querying a date is nothing to do with how your data is stored, right? Unless you are saying that you have a column which calls date, you can have similar mapping in document store also. So you can have an attribute called date. Key value does not have any structure at all, so it's totally free flow, fully flexible. But column store, document stores, you can have attributes which are date, and then you can query for it. You can do the translation, everything. So depending on database you are using, all these features are provided in NoSQL databases also. In SQL, we always use aggregate function for processing the data. Yes, data aggregation is possible. HBase is a good example. HBase has data aggregation functions. So all of these NoSQL databases give all these data processing pipelines, aggregate functions, etc., so that you can process those data. Okay, and there are other systems on top of these NoSQL systems only for data processing and data pipelining. Okay, so some systems are good just to store, like key value stores, where it's very good to just keep data, and the whole processing is done on top using another system. Okay, but some like HBase gives aggregate functions. And others, I don't understand the questions. It's data, is it classroom training or online only? I don't know. If classroom, then where it isn't checked in located. I think it's a question for digital Vidya, but I don't think there is a training right now on big data, on digital Vidya at least. Any more questions, follow-up questions? So I think it's a good time we can start that small quiz, Divya.
Sure, Rohit. Thank you so much. So, guys, we are launching out some questions onto your screen. Um, just select the answer for each question, and Rohit will simultaneously share the correct answer once you put in your option. So, here's the first question on your screen. We'll give out 30 seconds for each question. So, quickly select the option which you feel that is the correct one. 10 more seconds to go, guys. Quickly fill up the um, quickly select the option which you think for the question is correct. And we have received around 70% of the responses. Okay, great. So, Rohit, what do you think? What's the right answer?
So I think the if you saw the poll answer is correct. So graph is used for social connection, social network data. And
Yes, absolutely. So, let's move to the next question. Here is the question. Another 30 seconds for this question, guys. NoSQL databases is used mainly for handling large volumes dash data, unstructured, structured, semi-structured, or all of the above. Received 50% of the responses. 5 more seconds, guys. Great. We have crossed 70%. Super. So, Rohit, what's the
okay,
right
so
answer?
most of the people have said all of them mentioned, but that's not correct. So I agree with people who said semi-structured also, but the correct answer is unstructured because it says mainly. So mainly NoSQL database is used for unstructured. For semi-structured, people coming from different backgrounds still prefer to try to do SQL. But if it is unstructured, no, mainly for large data volumes, NoSQL is the main choice. Okay, next question.
Thank you so much, Rohit. Next question is launched on everyone's screen. Super. 40% of you have already responded. 10 more seconds. Great. Rohit, over to you.
So majority seems to have given the right answer. So it's key value.
Yeah. Thank you so much, Rohit. Launching out the next question. Another 30 seconds for this question. 10 more seconds, guys. Okay, Rohit, what's the right answer?
Again, majority has given right answer. So Cassandra is the white column data store.
Thank you so much. Next question is launched on everyone's screen now. 50% have voted. 5 more seconds, guys. Rohit, what's the right answer?
So here the majority is not correct. So it's definitely no. So
Thank you.
no, Hadoop is not a database.
Let's move to the next question.
This I think everybody will correctly answer. It's very simple.
5 more seconds, guys. Okay, so now there's a shift. Rohit, what's the right answer?
So as majority said, PostgreSQL is not a NoSQL system. It's a SQL-based system.
Thank you so much. Launching out the third last question from the quiz. We have two more questions after this one. Guys, quickly vote in. We are waiting for a response. 5 more seconds. Okay, what's the right answer, Rohit?
So as everybody said, is correct. Dealing with large data set is the best scenario. The last option.
Thank you so much. Let's launch down the second last question. Okay, now we have started getting some responses. 10 more seconds, guys. Superb. Rohit, what's the right answer?
So majority is right again. It's second option, supporting distributed data set.
Okay. And here's the last poll for today's session. Another 30 seconds for this question. Right. Yes. Even we'll have more clarity. No. Okay. So guys, 10 more seconds for this question. We have received 50 plus responses. Just 5 more seconds. Okay, Rohit, what's the right answer?
So it's all of the above. All of them
Yeah,
are big players now.
super. Thank you so much, guys. It was great having all of you share and be such an engaging audience with the quizzes. We loved your responses, and we were so glad that most of you actually responded to all the questions in majority, and most of those answers were correct. So thank you so much for being such an interactive audience, and thank you, Rohit, for taking up such an amazing session today. We
Thank you.
glad and we really enjoyed the quiz for sure.
Thank you.
Thank you. So here is another poll I have for all of you. Um, if you're interested in any data science course, just select with uh, sorry. Uh,
Hi, just joining in.
okay. Um, so let's just fill in the poll with your response if you're interested in a data science course. And we have the final poll regarding the feedback. Just give me a minute and then you all can enjoy your week ahead, or maybe probably join back your work for sure. So, share out your experience for today's webinar, whether you loved it, you find it good, and in the poll section. And thank you so much, guys, for being such an amazing audience. It's always great to connect with you all. You all will get the recording, you all will get the presentation delivered to you over an email. So, do not worry about that. Thank you so much. Bye bye. Thanks, Rohit. Bye bye. It's great having you here again.